Little before I jump into this, when I was a student here at Maryland, I worked at Goddard, NASA Goddard Space Flight Center in the Global Modeling and Simulation Division, which was I worked for a scientist there, Bob Atlas, who then after he retired from Goddard, went down to lead the AOML for NOAA, Atlantic Oceanographic Marine Lab, as part of OAR. So we had a chance to interact even, then just several years ago before he retired from there, as we supported NOAA's 2023 Hurricane Field Campaign with GeoCollaborate. And I'll tell you about GeoCollaborate and what we ended up putting together over the last 10 years under a program that the federal government has called SBIR, called Small Business Innovation Research. And it's the federal government's seed fund for small businesses and innovative ideas. And that's what we use to build a GeoCollaborate and make it so unique. So when I talk about GeoCollaborate, keep in mind that there's nothing else out there like it, because we ended up developing so that the federal government doesn't fund anything under SBIR that exists. It can't exist. It has to be a new invention. And so we did that and ended up getting a patent on data sharing and collaboration, which is really, really exciting for us. So we're going to be taking GeoCollaborate and applying it into this, how can we engage communities? Because for many years, 20 years or more, we have supported and done work with federal agencies, whether it was NASA, whether it was NOAA, U.S. Forest Service, and we really had saw a need to bring the power of that kind of data to communities so they could actually use it. There was so much work done in the research world and researchers talking to researchers that applying that data into real world decision making is something that we really found a great pull towards and a great need. So I'm going to talk about here building community resilience and enabling access to trusted data using GeoCollaborate and this cross-platform data sharing and collaboration environment. So I want to describe what GeoCollaborate is first. So we all know that a lot of people out there, a lot of agencies, a lot of organizations, a lot of universities have web portals, right? They build their web portals and everybody wants you to go to their web portal. And that was great when they first started coming on because there were great map interfaces to look at data. But now we have thousands of web portals. Lots of them are out there. And each one of them has particularly good data in areas where they're focusing on, whether they're gathering data and collecting it, curating it, and making it available. And so I've been through countless number of briefings, particularly in the hurricane world with Hurricane Research Division and others within NOAA, where their web browser looks like this, where they have 100 different web tabs open, and they just page through each one of those web tabs to highlight data and maps and things like that. Well, what GeoCollaborate does is it extracts data from those portals and hubs, and it shares it into a common operating picture, a collaborative map. So I want to, say first and foremost that we don't download and save data from anybody's portals or hubs. We point directly to them. So the use of GeoCollaborate actually helps the metrics for any of the portals that are serving data. Right. So if you think, hey, we have a portal here and we have these 6 data sets. We have some people coming to the hub, but if we can put this into an operational decision-making environment with GeoCollaborate, more people will be hitting our server for the data, and it'll really improve visibility and use of that data. So on the right-hand side, you see an interactive geospatially based map, which is pulling in disparate data sets from all these portals. And then we have what we call a real-time collaborative environment. So you have a leader that logs in, who can display data, turn it on and off, the upper left-hand side. And then you have followers that connect through a URL. And when they turn GeoCollaborate on, their map automatically zooms to match the map of the leader. It's not screen sharing. It's actual geospatial data sharing. So when the leader zooms in this particular case, we were supporting NOAA's Hurricane Field campaign last year, diving into Tropical Storm Tammy. We were tracking the P3 planes flying through the storm in real time. We were watching them drop dropsons, and then we could visualize the final observation right before splash of that dropson, and then compare that observation to ocean surface observing systems, whether they were buoys, sail drones, gliders that are being operated. So we could start to see and calibrate some measurements. So anybody who's a follower is following the leader in real time. And then on the bottom, there's a dashboard that just stays up and operating. And all the data layers on the left-hand side, right here, all the data layers that the leader turns on are available in the dashboard so people can turn them on and off themselves. So if you think about it, we're actually accessing disparate data from different trusted sources, and we're placing it on a map for people to determine if they want to turn it on and off. So we're spoon feeding users with data. They don't have to go search for it. They don't have to go data mining. They don't have to spend 80% of their time just looking for data. We're presenting them the data right in front of them. And then we can get right to work and start talking about the benefits of that data. So one of the projects that we're working on here is to provide disparate data integration for a community. And it's a community that we recently moved into in Annapolis. Cape St. Clair has about 7,200 residents. And it's right close to the Bay Bridge next to Sandy Point State Park, where we've spoken with the town manager and their board. And what do they want and need? It's very much a coastal community. They want currents and forecasts, tide level predictions, inundation predictions, water temperatures, wind forecasts, and local impacts from long and short-term weather and climate extremes. So we've spoke with them about building an interface that can become a community resilience dashboard to help them plan. And then we could just populate it with sensors and data that pop up and are available via web services. So that's what GeoCollaborate is able to do. So we went on an initial sensor location tour within Cape St. Clair. We had the folks. This was actually on May 24th when we had that Annapolis press conference, there where the president of the university attended. And they came over and we looked at various locations where we could put a water level sensor to feed that data into GeoCollaborate and into their dashboard as well at Honolulu. And so this is what we're talking about. Putting in water level sensors and getting that data into GeoCollaborate and then combining additional information and also getting students involved. So this is a group of students at Broadneck Senior High School. Broadneck has an environmental sciences program, and they have this project called Senior Capstone Projects, where the students have to find a community-based project to get involved in to put science information to work. Bingo, right? That's exactly what they would like to do and work with us here. They're working on oyster reefs and cleaning oysters because we grow a lot of oysters in Cape St. Clair and put them out into an oyster reef in the McAfee River to help clean the water there. And the teacher there, her name is Miss Allison Davis. When we spoke with her, told her about our project and geospatial data and putting sensor information in here, she says, my gosh, This would be a great capstone project for many of my students to get involved with. So we're pretty excited about that. So applying GeoCollaborate to local challenges, I mean, current NOAA tide level forecasts are not accurate. We're not going to paint any rosy picture. Why aren't they accurate? Because the resolution of the model is not good enough. And we see that all the time with tide predictions of how high the water is going to be. On average, it's down, it's off by about a foot with its tide predictions. There's nothing in place to measure water height that adheres to NOAA's acceptable standards in Cape St. Clair. Cape St. Clair has 3 marinas, and they have a serious need to monitor the water level. And if the water goes up above the dock level, then the electricity is compromised. And if they don't shut it off in time, it causes a big problem. We've had recent floods where some of the plankings have come up on the docks, started to float away. So there's a need to improve data accessibility, visualization, and use. And we need a technology that brings together data and provides easy to understand observations, forecasts, and impacts for local communities. We know that impacts are really critical. And if we can start to put together the science and observations that are out there with situational awareness for residents and town managers that know nothing about science, for the most part, then all of a sudden we're creating a brand new community of users that are going to turn around and tell their leaders that this science data is important and we need to have it. So I just did, this is a little bit old. It ends on May 21st. We've had many more, but I just did a search with the Iowa State website on how many warnings, advisories, watches have been issued for coastal flood advisory or coastal flood warning, and a coastal flood watch. The trend is going up. I mean, in 2024, as of May 21st, we had 17 coastal flood warnings in Anne Arundel County, or 12. And before that, it was less, but we've already had 4 or 5 more since then. So we can see that the warnings are going up and more coastline all along the Chesapeake Bay is threatened. As we all know, we can look around anywhere and see the stories of people losing property and coastal erosion happening. And, you know, we access the coastal flood, the coastal monitoring data as well. We can go down, we're 10 minutes from downtown Annapolis and take pictures of what the tide level looks like, mapping it to the sensor data. On the left-hand side is our boat ramp at Cape St. Clair. It's usually not that high, and there's downtown Annapolis. And so one of the other things that we've done is this is pretty amazing, actually. All I did was send an email to the director of NOAA Coastal Mapping Division. And I said, hey, you know, I've been looking at your data and I'm trying to get an inundation forecast for the Little Magothy River. And when I go in there on your map, it just shows this little tiny dot of colors in the middle of the Lower Magothy. And I'm like, what is this? I'm not sure what it is. Well, that sent off a whole flurry of email activity. And in the next 2 weeks, we were on a conference call with 20 people because I said we were going to put in a tide gauge there, a water level gauge. Or do they have any plans to increase the resolution of their model? And they do have plans. And we engaged them immediately in identifying a domain where they could increase the resolution from that on the left to that on the right. So it's their proposed local refinement for the STOF's 3D Atlantic model. And so they said, look, in the domain that you identified, which I included the Naval Academy in our domain, this is the Little Magothy River, which basically has hardly any grid points, 1. That's why I got 1 grid point right there, because that's where their grid is. But on the right-hand side, they'll be able to visualize the inundation and the tide level through the inlet of the Little Magathie into the Chesapeake. It's only 17 meters wide. 17 feet wide, sorry, not meters. So we're pretty excited about that. And they said, you know, we did a little analysis of the grid that I identified, and they said, you know, that would only add 1% or less runtime on our system to include this in there. And so they're prepped and ready to kind of do this once we can start move forward with our project. And so that's really exciting. And this model data can come into GeoCollaborate so we can visualize it. So applying GeoCollaborate to the local challenges, I mean, we have sea level rise impacting the community, the tide levels aren't accurate, extreme events occurring more frequently, docks, piers, electrical and plumbing, redistribution of sand impacting navigation. So they have a plan to do a beach replenishment in 2025 in Cape St. Clair, bringing in a ton of sand in there, and that's going to impact navigation and inundation forecasts as well. And the flood inundation forecasts are not detailed enough. So we're basically thinking we can take GeoCollaborate, we can put this additional science data in here, all the data that you're pulling together now with additional sensors, we can pull that in, show people what the data looks like in real time, get them up to speed on monitoring it every day. And then we can also produce things like video updates of what's the status of a storm or wind-driven tides. And those video updates can be accessed within GeoCollaborate too. They can just click on a link there and then see a briefing. And we've been doing testing with that as well online. So, you know, residents are directly impacted by this. They have costs increasing to protect the community, nowhere to get useful, trusted information. They're like, we have no idea where to find information. And I'll tell you, you know, we work pretty far up here with the data and getting data to work and pulling in model. The public is way down here. They'll Google something, and if they find a link that even resembles what they're looking for, they'll use it. And that's not good, because a lot of that is not trusted information. And so we also, this next gen engagement is really important. I mean, Ellen is a former dean at University of Miami Rosenstiel School. You know, to get students engaged with real data, making real decisions is the way to really empower our next generation. And visualizing the data is key. So we've also done a partnership with a group called Climate Central. And Climate Central has a vehicle called their Flood Vision vehicle, which has a LiDAR built into their roof, along with cameras, stereo cameras on both sides of the truck. And they came to our community, and it was awesome. So this is the path where they drove around Cape St. Clair, mapping the elevation of the community, and we did sample visualizations. Now, why are they doing this? Because we want to turn around what 1 foot inundation looks like to people in their neighborhoods. What does a 2 foot or 3 foot inundation look like? I had talks years ago with Bob Atlas when he was at AOML. We both were like, people are not going to evacuate. They're not going to listen to authorities until they can actually see their property inundated by a forecast, storm surge, until they actually see it. So here's an example. I didn't have the coast clear picture here. I forgot to put that in before we came down here today. But this is one of our marinas, Deep Creek Marina. This is a sample. This is a visualization, test visualization of a storm surge or a surge of 12 inches above the road level. Water height is 3 feet above local high tide line. This is what it would look like. Now let's take it higher. This is 4 feet above. This is 5 feet above. So this information, when we shared this with the town manager, he was like, oh my God, I've never seen anything like this before. This is incredible. This can really help us with planning. Here is one of the other marinas in Cape St. Clair. This is an example of 3 feet above local high tide. This is 5 feet above local high tide. And this is on the left-hand side. This is the flood vision vehicle. And on the little inset picture is GeoCollaborate showing a satellite image of that area that we're mapping. So we will be able to take inundation and show it on the map in real time, that we're able to visualize it like this. So that's why these tide sensors are important, getting more information here. This one is 6 feet above the local high tide line. And this is just a view. We kind of switched the camera over here, looking at this parking lot where there's a beach on the left-hand side there at Lake Claire Beach. And this is 3 feet above, 4 feet above, 5 feet above local high tide line. And then this is the park, the main park where a lot of people play. Now this is up, there's sort of a cliff or a steps to go down to the beach. So this is, I said, how high does the tide have to get for it to flood the park? This is 10 feet, 10 feet above mean high water. This is 12 feet above mean high water, which would be going across the park to the right and starting and flooding the road that's there. And one other one where the oyster beds are, this is looking towards the neighborhood. This is 4 feet above local high tide, 5 feet above, 6 feet above local high tide. So we're all about at Storm Center Communications, which is my company, and GeoCollaborate, putting trusted data to work. I'm also the co-chair of the ESIP, Earth Science Information Partner, ESIP Disaster Lifecycle Cluster, and the ESIP Wildfire Cluster. So we're spending a lot of time looking into areas where we can put trusted data to work, so people can understand it. This is beyond researcher to researcher. This is data to the people almost. Add those key data sets to GeoCollaborate for testing and eventually wide community access and use. Additional resource to Anne Arundel County, Annapolis residents, and work with University of Maryland to access additional data sets. How can we put more data sets that you guys have, that you're putting together, and get them on here? It's important to have a data portal, but we want to take all these disparate data portals and access data at the right time into the right environment so people can improve their situational awareness and decision-making. So improve access to higher resolution water level forecasts, monitor those forecasts for validation, provide feedback to agencies and organizations providing the data. So as you guys put more sensors out there, we will be connecting with the communities and then providing you with feedback. Hey, JT, we need to do this, with the sensor. Can we do anything with it? Can we add another, measurement here, an air quality or something, because people really need this information. And then all of a sudden we have great feedback because we have input from the communities. If all GeoCollaborate is a community-based data use and sharing environment for planning, decision-making, resilience building, science, and engagement. And let me just say that, it took us 7 years to make GeoCollaborate easy to use. It's not easy to make a technology easy to use. And that's one of the things that our users get back to us with. Say, you're presenting us with the data, and all we have to do is turn on and off layers that we want to see. And as long as we have data descriptors on what those data sets mean, we engage communities in meetings and can show them what it means. We can have question and answer sessions with them. And this is scalable. You know why? Because there are a lot of students in places, from what I understand. Last time I was here, there were 45,000 students at Maryland. I don't know how many there are now. But, there are students in high schools. There are students at universities. who want to engage communities. And I think this could be one of the fastest things that could scale up to get universities and show their own communities the benefit of what these universities are teaching these kids in their own local areas. So this is just a couple pictures back on August 26th. We were invited to come into the Annapolis EOC to talk with Director Simmons and Deputy Director Dave Mandel about how they operate, how do they use data, how do they use dashboards. And they were very interested and said that they see high hopes and a lot of promise in GeoCollaborate because we can bring in disparate data sets in this real-time collaborative environment. So that is something that we're really excited about. So I'm going to take I'll take a break here just for a moment because I did just want to show a little example of how GeoCollaborate works. We've been spending a lot of time over the last several weeks supporting hurricane response for a group called the All Hazards Consortium, which has 45,000 stakeholders in it. And it cuts across federal agencies like DHS, CISA, FEMA, and others, as well as state emergency operations centers. They're private sector liaisons and also private sector owner operator organizations, like in the communication sector, Verizon, AT&T, Comcast, the fuel sector, utility sector, all the investor-owned utilities across the country, and the transportation, medical supply, logistics, people who have to do transport. Because one of the things that they have realized is that they've heard there's a lot of information out there. They have no idea how to find it, no idea what to trust, and no idea how to put it to work to help their operations efficiency-wise. So we're working with the All Hazards Consortium to put GeoCollaborate to work. They've adopted GeoCollaborate, excuse me, to provide with them the latest weather and environmental information that they can look at and test to see if it helps and helps their operations, and also produce video updates for them related to hurricanes and impacts and things like that. So I didn't get the chance to put as much of stuff together as I wanted to within GeoCollaborate. But I'll take a pause here, see if there's any questions online, see if there's any questions here in the room, and then I can pull up GeoCollaborate and show you what that looks like. Okay. Thanks.
So you are very dependent on the source of the data that is available online. So if the source of the data is offline, like for instance right now, the Asheville, NCEI.
NCEI is offline, that's right. Yes.
So what would happen to have no way to access that information?
That's correct. If the question was, if for those online watching, if the source of the data that we're sharing is offline, and the example was NCEI in Asheville has been locked offline since Helene went through, is that data not available? And that is correct. And the reason that's correct is because we do not download and save and reserve any of this trusted data. A lot of our users have said, we want the data right from the trusted source. You know, when NCEI is knocked offline because of something like this, that's a big problem, right? And so I'm sure they're looking at other forms of backup communication in the future as they move forward. But we want the data to come right from the trusted source. If we're going to be putting, water level sensor data, Mesonet data from Maryland, into GeoCollaborate, we want it to come from you because you're the ones that are providing it. We don't want to add any other middleman into it, which also adds another level of, who might be able to get access to that data and change it, or manipulate it somehow. So we want it to come directly from the trusted source. Thanks. That was good question.
You have a question in the chat.
Sure.
Somebody asked, After providing these data set maps to the users, do they often come back inquiring for additional assessment, analysis support, such as extracting selected parameters and key locations, getting time sensitive or time series monitoring from the data sets?
Yeah, that's a great question. So I can boil, that's an excellent science question. I'll boil it down to what some of the users say. What else can you give us that will help us? That's what they say in their world. So yes, it's very interesting when you display a particular piece of information in GeoCollaborate and they see it, get explained, they hear the explanation of what it means. It clicks off ideas in their head. Well, do you have anything that might be able to help me in this area, which might be air quality, or, what about wildfire smoke? If there's wildfire smoke coming into our area, will we be able to see that? So the really unique thing, and it's exciting to see that GeoCollaborate does, is it starts to open up the minds of people who have never had access to data in this kind of way before. Right. And sometimes we'll say, oh, well, you use Google, right? And you're driving down the road and you use Waze. I mean, this data is coming from people that are reporting accidents, and Google's processing where your cell phone is, and they can use AI and figure out the traffic flow and give you back that information for backups. That's where we're headed with the weather data and the environmental data that we can access and put into GeoCollaborate, where it's a one interface, multiple disparate data sources that are being made available at different levels: federal, state, county, municipality, and any private sector organizations that have trusted data that they want to provide as well. I hope that answered that question. Okay, not seeing, sure.
So is that the reach of this project is national or is it global?
So GeoCollaborate will work globally. The collaborative environment will work globally. So we could actually collaborate with somebody in Japan or, in India in real time, move their map around, dive down and display data. Now, what's important is that we want to be able to identify data there locally that they're offering that we could pull in as well. So we've frequently pulled in different NASA data, GPM data for global precipitation, things like that. And when we add that to GeoCollaborate, it shows up on the whole global map. Yeah. Mm-hmm.
Looks like Louis has a question. Sorry, and I'll see if I can do it.
Sure.
Yeah. Can you hear me? Can you hear me? Hello?
Say something now, Louis?
Can you hear me?
Yeah, we can hear you.
Oh, great. Can you hear me now? Can you hear me now? All right. Listen, this is Dave, a really nice job. Obviously, you've been involved with this for a long time. So I just wanted to reflect on a weekend visit we had to Crisfield, Maryland. This was Tim, Mike Maddox, who manages the Grand Challenge on these water sensors along the one from, like you showed a picture of, and myself. We went down there on Saturday, and really was an incredible, enlightening experience in the terms of the challenges that they face. And one of them is the complexity of the rising water in Crisfield. Crisfield is on the eastern shore, just north, literally just north of the Virginia-Maryland line on the eastern shore. And their rivers that empty into the Chesapeake Bay will flood depending on wind direction. So they're very interested in monitoring the level of the water course, in wind direction. I mention this because there's some interest in getting a mesonet observation down there as well. Another person who was involved in this meeting on Saturday was Jeff Orrock, the MIC from Wakefield. And I asked, and he was talking about access to these coastal data that's being set up by the state of Virginia and now by Maryland, and that we should get that data into their system that's called HADS, Hydrological Meteorological Automated Data System, which is apparently an operational system that I've just become familiar with. Probably, we all focused on MADIS, which has the atmospheric data. The point here in bringing this up is that if we relied on the Weather Service bringing this data to the decision makers, the wet side would come in through HADS, and the atmospheric dry side would come in through MADIS. So I asked the program managers when I got back here, do these two data systems, data access systems talk to each other? And Dave, I know you're going to be shocked when I tell you that they don't. So a decision maker, if we just told them to access the mesonet through MADIS and access the buoys that Tim and Mike and the others working on the HydroNet, they'd have to have two different access points. So the question to you is, at this point, you didn't really mention much about the operational data. Can you bring the HADS and the MADIS data to your one screen here?
Yeah, that's a great question, Louis. And that's the whole idea, is to bring these disparate data sources together. So I'm not sure exactly the format that they have available and how they're making it available, but that can all be brought together once we speak to them and say, how is this data being offered? So that's the whole concept and the reason why GeoCollaborate was developed, to bring disparate data sets together. And they could be multiple formats. They don't have to be the same format. If they can create a KML, for crying out loud, of that data, we could bring it in today and bring this stuff together. And I think that's something where at least the community, the town manager in Cape St. Clair in Annapolis, has made that realization. And he's saying, are you telling me that you can bring into us all this data from NASA and NOAA and we can start to use it for our own benefit? They always thought that data was just for federal use. Isn't that sad, right? That's what
and these two data streams are designated as operational, publicly available data streams. And within the forecast office, and I talked to Orrock, the MIC, offline during the break, that they would have two separate systems for that within their forecast office. That's not a good thing for the decision makers, as you've shown. So anyway, I just wanted to make sure that people understood that even in the data sets that we as a university are now putting out there for local and state decision making, even if we go to the operational data sets, they're going to need they'll need multiple screens.
Yeah, that's true. And one of the other things that's really interesting, Louis, is that we came across when we were supporting NOAA's 2023 Hurricane Field Campaign last summer, is that the sail drones, the unmanned drones that they're sending out into the ocean, NOAA is basically leasing the data, from the sail drones. And the sail drone data did not show up in AWIPS, because the data was not, would take a whole modification of AWIPS to add that data format in. But what somebody did one tweak one time last year, and all of a sudden a ship symbol shows up near the eye of Hurricane Sam. And people start freaking out, like, what in the world is the ship doing there? When it turned out that it was a sail drone that was meant to be there collecting data. But the other thing is that we have access to on the research side to the Scripps Oceanographic Institute Lagrangian drifters. Those drifters are out there and they dropped 4 or 5 of them out of the P3 ahead of Helene before it made landfall. Within 15 minutes of those drifters hitting the ocean, they showed up in GeoCollaborate. And they're still not available on AWIPS. So you can have, AWIPS requires a certain data format to go in there to be used by operational organizations. And you have these wave spectral drifters that are out there, and I'm looking at 35-foot waves not too far off the coast. And the Hurricane Center didn't even have access to that. So there are many more opportunities to put various data sets to work. And, we've been working at it for now, 14 years. And it's time to bring it to the fore. My advice would be not to waste time trying to develop any portals. Develop the data serving and develop the data processing. And, maybe the state has to, you have to create a map where anybody can go to and look at it, but include the data being served in web services formats. So we can pull that out and we can make it available to many more mapping systems and GeoCollaborate. Ralph.
Yeah, so this is all very exciting and interesting. I had 2 questions. So one, what do you do if you've got 2 reports nearby that conflict each other? How does your system handle that, or is that just for the discussion lead to try to resolve? So that's one question. The second question is there any tailoring that can happen? Like, say you have a map piece that you use, if a specific jurisdiction wanted something really zoomed in at some other level, can you guys adjust your software, or is the map that you
Yes.
very can it go down to very small scale?
Sure. No, they're both great questions. And can they hear Ralph in the room?
It should be.
Okay.
Pretty good.
Okay, great. So for the first question, on if you're accessing 2 sensors that are not agreeing in observations, that's why OAR and HRD wanted to use GeoCollaborate to do validation and calibration of sensors. So we were able to take satellite data and ocean surface observations and sail drone data and pull that together. And if there was a discrepancy and the scientists looked at it and said, oh, well, okay, they were 1.5 miles apart, does a 5 meter per second difference matter? They're like, no, because there probably was a 5 meter per second difference in this hurricane, So they're like, okay, that's good. These 2 agree. So what GeoCollaborate can do is kind of advance and accelerate identifying if sensors are having an issue, right? So if you see one and they're really far apart in observations, then you look at some other ones around saying, oh, well, this one's probably working. There's something wrong with this one. Let's dive into that one and see what's going on. Let's look at the history. Let's see if it, got hit by something or something and made the observations go a little bit awry. So it can be a very positive thing. We don't turn sensors off, and just say we're not going to include that one because we think it doesn't look right. It's up to the people who are looking at the data. And if we produce video updates, we can say, we can issue geospatial messages and circle one of them and then have a message when you click on that circle, this observation seems a little suspect. Maryland or NOAA or whoever university is going to have to get out there and look at it to see. But you can always flag things that look suspect.
Dave, can I just
Yeah.
add that is that, remember, it wouldn't be us, it would be whoever the subject matter expert, whose job it is to put the curated data sets out there. That would be part of their job, might be to actually look at those data sets. Because we don't want to ever be judging we're not going to ever change any data or modify it, but the subject matter expert who is the leader, that would probably be one of their roles.
Right. So that's part of where I was going.
Yeah.
Yeah. Yeah, and your second question, Ralph, Ralph was asking about a certain jurisdiction, we'll say Charles County, if they wanted to focus in on Charles County, or down in Chrisfield, Louis, if they wanted to focus in on that. The dashboard is totally, they can focus in on their map and keep it there. Right, so if they want to keep the dashboard focused on Charles County, other data sets will be updating all around them. And then when data sets update on theirs, then their dashboard will update. So it's not just the county, any individual user can put the dashboard where they want it. And the dashboard can focus in on that, whether it's at a little tiny, Annapolis 7 square mile area of jurisdiction, or a county or a region of FEMA. They could just set the dashboard wherever they want it to be. Then they can zoom in on the data if they want. They can move around the country and see other types of observations and reports and things like that. But they can always set the level where they want it to be.
And one more thing to add to that, it can also be used with other mapping systems.
Okay.
So that it doesn't have to be what we're using to show you
Okay,
here.
that was my
Yeah, if somebody wants to customize it for their mapping system, GeoCollaborate can be integrated into that system. Absolutely.
Yeah, that's a good point, because one of the innovations in the SBIR was not just GeoCollaborate. I mean, we have it integrated into Esri's JavaScript, map environment, but it can integrate into Google Earth. It can integrate into OpenStreetMaps or whatever type of.
And it can be used on mobile devices. I just want to add one more thing before you run out of time,
Mhm.
because I don't think you're going to catch your demonstration.
That's right.
The public, we have proof of concept that the public likes this, and the ability to use video with GeoCollaborate, and Dave doesn't always like to toot his own horn, but I'm gonna do it for him. In the Hurricane Bill, he's been doing video updates using GeoCollaborate to show disparate data sources. And one of his recent updates, he had 500,000 views. Subscriptions on the site went from 300 up to over 7,000 in the past 2 days. And the overwhelming comments have been, this is the most informative presentation of the data. I understand it. Because it's Dave, as a subject matter expert, bringing up layers on one map, explaining them about the forecast. It's blowing up as we speak right now. And they're saying this is the best presentation they've seen. So it's kind of a proof of concept. And
Yeah.
I know we would love to show it. We've been kind of running crazy getting it done, but that's what's happening right now.
Yeah, I think from a public perspective and decision makers too, they're just, they're so far behind on understanding data on a map, right? I mean, I spent 10 years on Channel 4 in Washington, pointing to Washington saying, here we are in Washington. Here we are in Washington, because people don't know where they live on a map. And then you point to other areas geographically. So taking the leap of displaying data on a map, as long as you can explain what it is, they really understand it. And, I think meteorologists have a tendency to throw a lot of things on a map because they understand what's going on. And that's how they've been taught, with 500 millibar charts and all the different layers and observations and stuff, being able to think in 3 dimensions. But the public doesn't do that. And there's a question, there's a chat here. You want me to
Yeah.
read it? I see the chat. There's a chat here that I have displayed. Let me see if I can break it a little bit. So it's following up on a previous question. To what extent does your tool depend on stability in these web pages? Should they be updated by developers? Put another way, what kind of tools and techniques do you implement to regularly web scrape, collect your data from these different sources in a way that it doesn't break? Great question, Peter. Thanks for that. So the great thing is that we don't web scrape. We don't do any of that stuff. We access the web service address for that data. So what's important is that if your web developers are updating things, you do not change the web link. If you do change the web link, send out an email to those people that are accessing your data sets. So what we do is when, and I'll just, as I'm talking, and Ellen's right, we won't have time for the whole demo, but I'll bring up I'll bring up the web page here. Yeah. So this is GeoCollaborate live right now, and I'm pulling data. You know, this is my own sort of personal one that I use to test things. But down here, we're tracking a guy who's riding his bike from Delaware to Key West, and he's down in Homestead now, and I told him to stay there. Don't go anywhere else. Don't go out on the Keys when the storm's coming. So, but if I zoom out, I've got a sea surface temperature map. That's the mirror data set from NASA JPL. And then we have wildfire data that's coming in from the Forest Service and the NIFC. So you can click on any one of these and see what kind of data sets these are. Wind-driven runs are happening right now with this particular wildfire, and you can dive into it closer, and you see the weather radar data on there. So what's happening is that in GeoCollaborate, we're pulling that data feed from that web service. So you can do all the upgrades you want to that data service. You can enhance it. What we really like is when somebody gives us good feedback on a particular data set, we will ask them to make the attribute table much more useful and understandable by regular people, not just dump the whole data set in there. That way the public can click on that data set and see what's happening. So did that, Peter, I just want to make sure that answered your question. We don't go and web scrape. I know a lot of companies do that. They web scrape a lot of data sets. We link directly to that service, because then we can say we're pulling that data directly from the trusted source. And the way GeoCollaborate works is that all the followers out there are pulling from the source that the leader says, right? So the leader is directing where people are pulling their data from. They don't have a choice. And the other thing is that nobody who's following can download and save the data. So this is all about situational awareness and all about improving the use of science data. It doesn't allow, I mean, we could allow, but we don't. It doesn't allow the users to download, save, then manipulate and re-upload data. It's only there to look at.
We do have a way to provide links. If people want to go to the source and download.
Oh, yeah.
On their own.
Yep.
Put links into the window, KeyPoint's window, so you can go do more with the data and go to the source directly.
Yeah, exactly. And so that's really the benefit of GeoCollaborate, because I'll make one point here, and I know we're a minute off, is that we spent a lot of time looking at various data sets and trusted data sources. And we have been sort of friendly pounding on NOAA to make their data sets available as web services. And they have finally, over the last several years, have a whole migration plan to get their data in the cloud as web services, GIS web services. So as you migrate to the cloud and you think about migrating to the cloud, that makes the data even more responsive, right? So if you're serving it locally, you know, that's good. But if something happens at that local area and you get cut off, that's bad. But if you're also uploading it to the cloud and that's a source of the data, then that's really good, because you can lose power locally and you'll still be having the data in the cloud. So we can pull from anywhere. We can pull from any cloud. We can pull from local organizations. But the way GeoCollaborate works, and I mentioned this in the beginning, that it helps your web metrics. If I'm collaborating with 100 people or 1,000 people, it doesn't matter. This all operates in the cloud. It's all in AWS. It could be in Azure. It could be in, you know, anybody's cloud. That when we share a data set to the number of collaborators, they're going to immediately go to your data to display it, because I told them to. And then they can click on that data on their own maps. They can interrogate the data, see what it means. So we're spoon feeding, hand delivering data into their mapping environments. They don't have any idea where the data comes from, but they can focus on what it means to them and how they can use it.
Well, they do know where it comes
Yeah, well, it's a trusted source,
Yeah.
but I'm just saying, like, when you bring up a wildfire data set, if I bring up the hotspot data from NASA firms, it's not obvious to them, it's NASA firms data. They could click on it and they'll see NASA firms and the NASA logo. So it also leads you down the path of being able to display, think about how you want your data displayed. Right? If you want people to know this is from the University of Maryland Mesonet, then put the Mesonet logo in your metadata, right? Put the logo of whatever you want to put as far as the source goes. And when you click on it in GeoCollaborate, it'll come up. And that's attribution. And I hear that all the time from wherever I give talks. What about attribution? You're stealing our data. You're just putting it up there. No, we want to give everybody attribution and we want to make sure that they see you as a trusted source. So that's it. Now we're 4 minutes over, but I really appreciate everybody's time, and it looks like there's one other chat comments. Oh, Peter, thanks. Okay. Awesome, Peter. Thank you. So thanks, everybody. I appreciate your time and the invitation. I was going to say before everybody left that you could actually connect, if nobody has their computers or whatever, you could connect to this URL and I could move your map around remotely in real time and turn data sets on and off. So it allows you to brief an emergency manager in Charles County from here. Right. And Louis, I don't know, Louis, are you still on?
Yes, he's still in there.
He's still in there. So, one of the things that I've heard from the National Weather Service perspective, and Ken say, is that he wants to put a meteorologist in every emergency operations center around the country. That's his goal. Well, that seems to me to be kind of unrealistic. But if you had a technology like GeoCollaborate and they could manipulate and move maps in every EOC in the country, then you would have a virtual National Weather Service meteorologist in your EOC, turning on and off data sets that are important for their decision making and setting up their dashboard in ways that they can then work with the data. So typically they give PowerPoint presentations that are briefing emergency operations centers. Those PowerPoints don't update. But if they give a briefing through GeoCollaborate, and then the dashboard that's left behind is always updating. And they have a one-way chat that they can put in there, or we could integrate in NWS chat, which is Slack now, integrate that into GeoCollaborate. So they could have real data and then have a meteorologist explain what it means anytime they want it. So that's my vision, but we'll see what happens in the future. Thanks, everybody, for watching online. Yeah.
Another check.
Oh.
We just said he's still
Oh, okay. That's cool. I don't know if you just heard what I said, Louis, but I'm not going to repeat it.